Genique. Next question is this one. Observe this. So it is related to the magnetic fields. Okay, how to find the magnetic field intensity due to the current carrying wire? Already we have seen the magnetic field intensity due to the infinite length current carrying wire, and it is also related to that one only. Okay, but there is a small thing you have to notice here. So here you have to notice what is an infinite line and what is a finite line. Okay, so here what is an infinite line and what is a finite line? Okay, suppose what is the question is given, a 5 ampere current is flowing along plus y axis to plus x axis from y to x. Then find the H field intensity at the point 3, 4, 0. Okay. So this question is somewhat tricky. Okay. And if you know that concept, and it is very easy for you to solve it. Okay. See, observe this thing. So this is current is flowing from plus y to plus x axis. So the current is flowing from plus y to plus x axis. So that means the current is flowing from plus y to plus x axis. So that means it is from the line is on the plus y axis and the current wire is on the plus x axis. Its meaning is that, okay, the current is flowing on plus y axis and plus x axis means what? Means what? He is saying that the current carrying wire is on the plus y axis and plus x axis. So this thing, this is the origin. Okay, the current is flowing from plus y to plus x. The current is flowing like this. The current is flowing like this. How much current? It is a 5 amperes current is flowing. 5 ampere current is flowing. Okay. Now you have to find the H field intensity due to this current carrying wire at where? At the point 340. 340 means it will be 3 somewhere. Okay, 340 means the 3 will be somewhere here. 0, 1, 2, 3. The point will be 3 and 4 means somewhere here. Here is the point. So it is the point of interest. Here you have to find H. Okay. So now there are two lines presenting here. One is this line and second one is this line. Okay, how can we find? We didn't have the relation for this kind of line, right? Till now we didn't find any relation for finding the magnetic field intensity, this kind of line. So that's why for simplifying this problem, I am dividing this kind of line into two parts, line 1 and line 2. Okay. This is line 1 and line 2. What is this line? Current carrying wire, wire 1 and wire 2. Okay. So this is, so can I say this one is an infinite length line? Infinite length current carrying wire? Can I say? So see, this is from 0 to plus infinity. This is from 0 to plus infinity. Even though this is going from 0 to plus infinity, okay, this line cannot be said as an infinite length current carrying wire. Even though this is also cannot be said as current carrying wire, infinite length current carrying wire. The infinite length current carrying wire is said, only the line is said to be the infinite length current carrying wire if and only if the wire is from minus infinity to plus infinity. Okay, but here this is from plus infinity to 0, 0 to plus infinity, and this is from 0 to plus infinity. Okay, this cannot be said as what? The infinite length line. Now, till now we didn't learn any concept of finite length current carrying wire. Now this is what? It is a finite length wire. It is a finite length wire. It is also finite length wire. Okay. So how can we find the finite length wire current carrying wire? How can we find the magnetic field intensity due to the finite length current carrying wire? Let us suppose I am taking a finite length current carrying wire A and B. Suppose if I want to find the magnetic field intensity at any point P, okay, the magnetic field intensity at any point P. So how can we find due to this? Let us suppose the I amount of current is flowing from point A to point B. It is a finite length. Okay, suppose if I want to calculate the magnetic field intensity at any point here, the expression for this is, it is given as, for this what I have to do? I have to do small work here. So this is the radius, it is rho. We know it is the rho means what? The radius from the current to the point. It is rho. Okay. Now I am naming this one as alpha 1. I am naming this one as alpha 2. Okay. These are the alpha 1 and alpha 2. We have to follow this notation only. We have to follow this one is alpha, this one is alpha 1 and this one is alpha 1, this one is alpha 2. If the current is flowing from this side. Okay. So suppose alpha 1 is nothing but from which side the current is flowing. The corresponding angle is taken with this bisection is alpha 1. Understand? So remaining is alpha 2. Suppose if the current is coming from here, then this one will become the alpha 1 and this one will be the alpha 2. Understand? Suppose if the current is coming from here, from in this direction, then this one will be the alpha 1 and this one alpha 2. Okay. So now take this one as the current direction. Okay. The current is flowing like this. The current direction is very important here for finding the magnetic field. For this kind of finite length line, then the H field at this point here is I divided by 2 pi rho, I divided by 2 pi rho sine alpha 1 plus sine alpha 2. Okay, sine alpha 1 plus sine alpha 2, and it is, what is the direction? The direction is current direction. Let us suppose the current direction cross radial direction. Suppose if the current direction is in Z, it is in rho direction, then this will be, we know this is A phi. Okay. So we cannot say it will be in always A phi, depending on the current direction and the radial direction. Okay. So that is important. What? Current direction cross radial direction. We cannot say it is phi. Okay. It is, I can clearly write what? Current direction cross radial direction. So for here I am writing A phi. No problem. So this is the relation for finite length line. Now we concluded that it is not an infinite length line. If it is an infinite length line, I can happily apply the formula. What is that formula? H is equals to I divided by 2 pi rho A phi. I can use this relation, but it is not a infinite length current carrying wire. It is not an infinite length current carrying wire. Understand? So for this kind of problem, so I have to use the finite length current carrying wire concept. Okay. So first of all, I want to find the magnetic field intensity due to the first line. Suppose if I want to find the magnetic field intensity due to the first line H1, is equals to, due to the first line for this, sorry, this is what? It is not 2 pi rho, this is 4 pi rho. Observe this is the, correct it, this is a 4 pi rho. Okay. This will be equals to I divided by 4 pi rho sin alpha 1 and sin alpha 2. Okay. What is I here? What is I here? I is nothing but 5 divided by 4 pi rho. Rho is nothing but what? The radial distance. The distance from the current to the point. Rho is nothing but what? The distance from the current to the point. So what is the distance from the current to the point is giving you rho. So this is the rho here for this. What is the rho here? 3. From here to here, what is the distance? It is 3. What is this point actually? This point is given as 3, 4, 0. It is 4. It is 3, 4, 0. Right? So here rho is equals to what? 3. So that's why we have to write rho is equals to 3 here. So what is alpha 1 and alpha 2? What is alpha 1 and alpha 2? Okay? We have to take the edge point. How to find the alpha 1 and alpha 2? We have to, you can write the alpha 1 and alpha 2. You can identify the alpha 1 and alpha 2 by joining the end points to this point. Okay, for this, what is the end point? This is the end point for this line 1. So suppose if you join this end point to this line, and how can you join the end point? The end point is at infinity. So for this, the infinity, from infinity, the end point line, the line joining the end point to this point will be like this. Understand? Because the point is here, there is an inclined line, but the point is, it is at infinity. These two they meet at infinite distance. So now what is alpha 1? The alpha 1 is nothing but from where the current is flowing, corresponding to that the alpha 1 must be taken. The current is flowing from here to here. Okay, so this one at this place, alpha 1 will be this one. For this, it is 90 degrees. Okay, because they meet at infinity, so that's why here it is making alpha 1 like this. They meet at infinity. Suppose if the current is flowing in this direction, they meet at infinity means then this angle will be 90 degrees. Then what is alpha 2? The remaining, this one is alpha 2 for this line. Understand? So now I divided by 2. So this will be what? Into sine alpha 1. Sine alpha 1 is what? 90 degrees plus sine alpha 2. What is sine alpha 2 for this? The sine alpha 2 for this is, sine alpha 2 for this is what? For this sine alpha 2. Sine alpha 2 is equals to opposite divided by hypotenuse. What is the hypotenuse? This is the opposite divided by hypotenuse. This is 3 and this is 4 and this will be 5. You have to write. This is 5. Understand? So this is 5. So that's why sine alpha 2 is equals to what? Sine alpha 2 is equals to 4 divided by 5. This is the 4 by 5. Now, what is the current direction? The current direction is, what is the direction of the H field at this place? The H field at this place, the direction of the H field at this place is, the direction of the H field at that place is what? The current direction cross, what is H field direction? The current direction cross the radial direction. What is the current direction? The current direction is negative AY. What is the radial direction? Radial direction is what? This direction. What is this direction? This direction is nothing but positive X direction. Right? So, the current direction. What is the current direction? AY direction minus AY direction Negative AY cross, what is this? Radial direction from the current to the point. This direction. Okay. So this is plus AX direction. So from this, what can I write? 5 divided by 12 pi. This is 1 plus 4 by 5. Okay. So here you will get 5 will get cancelled. Here it is 9 divided by 12. So 9 divided by 12 pi AY cross minus AY cross AX. Minus AY cross AX is what? AY cross AX is what? The third vector. The third vector AZ. But after this there must be Z. But here is X means it is negative X. Negative X, one more negative. So that means there is a positive Z direction. Okay. So you can simplify this. What is this? 9 divided by 12 means what? It is 3 divided by 4 pi AZ. Okay. 3 divided by 4 pi AZ. So this is the magnetic field intensity at this point. Now, so what will be the magnetic field intensity due to this line at this point? So for this, how can we find? For this, how can we find? So we remove the previous analysis. So if you observe this, how can you find this? I divided by, what is I here? I is equal to the same current is flowing, right? 5 divided by 4 pi rho. Rho is nothing but what? Rho is nothing but the distance from the point from the current. It is the distance. Now it is the rho. Here it is rho now. Rho is equals to 4. From here to here it is rho now. It is the distance due to this current. I have to find the magnetic field intensity that place. So here it will be 4. Okay. 4. What is sine alpha 1 and sine alpha 2? So for this, what is sine alpha 1 and sine alpha 2? See, this is the line. So we have to join the endpoints to this point. I have to join the endpoints to this point. Already it is joined, but it is what? It is, the current is flowing from this direction. So that's why it is alpha 1. And from this side, what is the endpoint? It is at infinity. But for infinity, what is the angle made here at this point? This is alpha 2 is equals to 90. Okay. So from this, I can write sine alpha 1 is what? Sine alpha 1 is, what is sine alpha 1? Sine alpha 1 is equals to opposite divided by the hypotenuse. This is the opposite. What is this opposite? It is 3 divided by the 5. Sine alpha 1 is 3 divided by the 5. Sine alpha 1 is 3 divided by the 5 plus, what is sine alpha 2? Sine alpha 2 is 90. Sine 90. It is 1. So finally you can write 5 divided by what? It is 16 pi into, it is 3 by 5 plus 1. Okay. Then what is the direction? What is the direction? The direction would be what? The direction would be the current direction cross the radial direction. The direction of the H field is the current direction cross the radial direction. What is the current direction? The current direction is this one plus x. Okay. The current direction is plus ax. Then what is the radial direction? Radial direction is nothing but from the current to the point. You have to read that. From the current. This is the current here. Okay. To the point means this is the radial direction. What is this radial direction? Y direction. What is this direction? Plus AY direction. Okay. AY cross ax cross ay. So finally, if I simplify this, what I will get? Here you will get 5 will get, here 5 is there, 8, here 8. So 5 will get, here 8 will be there. So 1 divided by 2 pi, 1 divided by 2 pi Az. What is ax cross ay? Ax cross ay is Az. So this is the H2 due to this. Now what will be the total magnetic field? The total magnetic field at this place is at the given point. Okay, the total magnetic field H at the given point 340 is equals to H1 plus H2. What is H1? This will be equals to 9 divided by 12 pi. What is this? 3 divided by 4 pi. Plus, it is Az. So no need to bother. You can directly, happily add this 1 divided by 2 pi into Az. This is a 4 pi. This is 3 plus 2. This is divided 5 divided by 4 pi Az. 5 divided by 4 pi Az. So this is the final answer for this. So this is the magnetic field. The magnetic field will be having this much quantity and it is having plus z direction. Okay, plus z direction. What is plus z direction? How the magnetic field? The magnetic field is positive z direction. So positive z direction means this is x direction, this is y direction. What is the positive z direction? This direction. That means at this point, the magnetic field, at this point we got what? This is the strength and this is the direction. So at this place, the magnetic field will be outward. This direction, outward from the board. So that means it is outward from the board means I can write outward means like this. So how the magnetic field? I am writing this one. It is coming out of this. It is from here what? It is coming out of this. It is coming out of this. It is coming out of this. So that means so what is the direction? This is the direction. Out of this. So it is positive z direction coming out of the board. Actually the field will be like this. It is going like this. So it is coming and encircling this. It is coming and circling this. It is coming and circling this. Here, here, here like this. Understand? So this is the magnetic field oriented around this current. Okay, always the magnetic field will be around the current only. Okay, so don't think that it is in z direction, the magnetic field will go straight. It is wrong. Okay, the magnetic field will be out of the board and it will into the board. At this point it is out of the board. Okay, it is coming like this. It is coming like this and encircles this. That is the meaning of this question. Okay, so you have to identify in this question. Suppose if you consider this one as the infinite line, this one as the infinite line, and if you do that approach, what happens? If you do that approach, it will be wrong. I divided by 2 pi rho, I divided by 2 pi rho. So that is the wrong. You will get wrong answer. Right? So this is the approach you have to follow when the line is from 0 to infinity. So the line is said to be infinite line if the line is extending from minus infinity to plus infinity. If it is from 0 to infinity, then that line cannot be treated as the infinite line. Okay. So this type of questions you have to consider. So this direction, magnetic field direction, is very important. Okay. Thank you.